All right, on worksheet 4, question 12, we're asked to find the molar solubility of iron 3 hydroxide. Molar solubility is X. That's what we're looking for, the maximum amount that can dissolve. If they were asking for the solubility product constant, they would have used the word constant, okay? Or they would have used the symbols KSP. So we're basically trying to solve for X. We know the concentration of hydroxide in this solution. They gave it to us as 0.05. So they're saying that the hydroxide came from some common ion. Maybe I dumped sodium hydroxide or lithium hydroxide or something else into the solution, and they've already figured out for us how much hydroxide there would be. So let's do our big 3 steps. We have iron hydroxide, so Fe OH in brackets 3 is going to break down to give us iron and hydroxide. Hydroxide ions have -1 charge. 3 of them means I have to put a 3 here. 3 minus 1 tells me the charge on that ion is +3. So because this is a common ion question, rather than just doing a molar ratio, which I can, this will be X to X to 3X, I know that I'm probably going to have to do an ice chart to figure out the values. And anytime we have 2 different salts, we probably have some stuff changing, so we'll do an ice chart to figure out those values before we put them into the solution. We're also going to get the KSP expression, though, from this balanced equation. KSP is going to be the concentration of my iron plus 3 ion times the concentration of my hydroxide minus 1 ion cubed. Okay? So we have 2 different salts here. We have iron hydroxide and some other kind of hydroxide salt. And we don't have a lot of information. We could go on page 969 of our textbooks and get the KSP value, 2.8 times 10 to the minus 39 is the value of the KSP. We don't know the concentration of iron. We know that it's going to be some unknown value X. We also don't know the concentration of hydroxide. It'll be 3 times the concentration of the iron though. But to that amount, whatever the amount was, this 3x amount, the change is we're going to add 0.05 to it. And the total is going to be about 0.05 at equilibrium. Now 3x plus 0.05 is still probably going to be 0.05. The clue that I use to figure that out is I look at this exponent, minus 39. If I multiply these values together, even cubing hydroxide, to get a KSP with minus 39, those values are small. So that means when I take 0.05 and add it to that 3 times amount, it's going to be 0.05 something. It's just going to round right back out again. Again, the common ion is essentially all there is. So putting these numbers into the brackets, I know the concentration of hydroxide will be about 0.05, which we're going to have to cube. I can see that iron's concentration is still an unknown. So now we just have some simple math. We're going to solve for X. So we want to cube 0.05 first and then bring it over as a denominator. So we're going to divide this by the cube of 0.05. So 0.05 cubed is 1.25 times 10 to the minus 4, so that cancels there. This will give us our value for X. And when we solve for X, a value of 2.24 times 10 to the minus 35 is our value for X. Now, again, don't get into the habit of stopping at the math. Make sure you answer the question. At this point, we've just done math. The final answer then, what is X? X is the concentration of that iron plus 3 ion, which was what was asked in the question.